NASA scientists now had a wide range of studies and experiments to carry out on the lunar surface after the Apollo 11 mission, which saw the United States finally send a man to the moon. During some of the subsequent missions, astronauts played golf or operated rovers, but the Apollo 14, 16, and 17 crew members also had a unique device to carry out a specific series of tests. The Apollo Lunar Surface Experiments package included a variety of scientific tools for the astronaut teams to employ, one of which was a space mortar to detonate explosives on the lunar surface. The goal of this active seismic experiment was to utilize these explosives to investigate the subsurface structure of the moon, but due to a number of challenges caused by a still unknown lunar phenomenon, the astronauts and engineers back home had to come up with some inventive solutions. NASA says the Eagle has landed. Putting a man on the moon and safely returning him to Earth was the primary objective of Apollo 11. Secondary goals included scientific exploration by the lunar module or OLM crew, deployment of a television camera to transmit signals to Earth, deployment of a solar wind composition experiment seismic experiment package, and a laser-ranging retroreflector during the exploratory phase. On July 16, 1969, Apollo 11 was launched with a crew that would go down in history as American and global heroes after being defeated by Commander Neil Armstrong's Command Module pilot Michael Collins and Lunar Module pilot Edwin Buzz. Although Kennedy did not live to see the achievement, a stranger left flowers and a note on his grave hours after Apollo 11 touched down on the moon. The note read, "Mr. President, the Eagle has landed. Active seismic experiment just as Apollo 11 did before." On July 20, Aldrin would be watched by over 650 million people. The world was captivated by Armstrong's words when he set foot on the moon and said, quote, "That's one small step for a man, one." For the purpose of studying the lunar near-surface structure, NASA states that the Active Seismic Experiment, or ACE package, was created to generate and monitor seismic waves. A rocket-launched grenade motor package, an astronaut-activated thumper device, and the impulse from the lunar module's ascent. Specifically, NASA astronauts had to detonate small controlled explosives on the lunar surface and measure how seismic waves traveled through and across the ground, because the moon is not seismically active, and the active seismic experiment was designed to gather data to determine the physical properties of the lunar surface and subsurface materials to determine the structure of the upper kilometer of the lunar crust. Since seismic waves have been used to learn most of what scientists know about the Earth's layers, including how the crust, mantle, and core react to them as they move through the planet, changes in the expected arrival time of the waves are used to infer information about the Earth's interior structure. Seismic tomography is the procedure, and there are two ways to get the data. The first method, known as passive seismic, involves installing seismometers to record seismic wave information from far-off earthquakes. The second method, known as active seismic, involves creating seismic waves by dropping or thwacking heavy objects to the ground or setting off explosions in the ground or water. Because the lunar environment was largely silent, seismometers on the lunar surface did not detect much activity, and NASA Resort did not use these methods. According to Apollo results, no significant moonquakes could be seen or detected by seismometers installed on the moon. Although the devices allowed researchers on Earth to map out a trunk of the moon's interior, they needed the assistance of active seismic procedures for more thorough research. The crew from Apollo 14 arrived at the moon with the first seismic experiment package. It included the specially designed mortar geophones and 22 explosive thumper charges. While the Earth experiences multiple magnitude 5 earthquakes per week, only 3 of them were detected by NASA in more than 5 years. Although it was activated by the astronauts, the mortar device could only be fired by NASA radio command from back on Earth. The astronauts successfully fired 13 of the 22 thunder charges, and the misfires were attributed to dirt acclimation in the firing switch. Nevertheless, they served their purpose, and the effect of the waves was detected by the seismometers. Unfortunately, the astronauts were unable to fire the mortar because they were concerned about damaging other equipment. NASA made an attempt to fire them after the crew left, but to no avail. Those explosives are still on the moon today. The Apollo 16 crew was then given the task to fire them, and they were successful in firing 3 grenades at a distance of about 900 meters. The 4th round was never fired because the pitch sensor went off, and the astronauts thought it was a grenade that damaged a ranging wire. In order to gather lunar data more effectively, the astronauts, including geologist Harrison Schmitt, placed the explosives 3.5 kilometers away from the geophones that recorded the blasts and seismic waves generated by the impact. No more research of this kind has been attempted since Apollo 17, but a lot of the information gathered during those significant and historic missions is still being used today. We appreciate you watching our video. NASA noticed that such velocities are significantly lower than those of intact rock on Earth, but are consistent with a fractured material produced by the prolonged meteoric bombardment of the Moon. For more thrilling historical stuff, like and subscribe to our Dark Documentaries channels. Also, let us know what you think of these unusual tools that the Apollo crews utilized in the comments section below.